In this type of problem, we're talking about a test charge in an electric field and what's the force on it. Or what's the charge of the electric field if we know the force and the charge of the test charge. In this example, we've got a test charge of positive 5 microcoulombs, and we know that that equals 5 times 10 to the negative 6 coulombs. And it's placed in an electric field that exerts a force of 0.0030 newtons. Now that's very small, but a charge is typically very small. And you're asked to find the magnitude of the electric field at that location. Now the equation for this is E, and in this case E does not mean energy, it means electric field. It can be complicated, so if you want to write it as EF for electric field, to help you remember it better, that's perfectly fine. I'll accept it. So the strength of the electric field is equal to the force divided by the charge. So in this case, the strength of our field is equal to 0.0030 newtons divided by 5 times 10 to the negative 6 coulombs. And we drop the net positive and negative signs here because, again, like we talked about in the last page, with charges, positive and negative means different. It doesn't mean direction. And so with forces, it does mean direction, and it indicates something that we don't actually know about this. So we tend to drop them when we're doing electricity. When we do this division, and we round to the two significant figures that we should have, we get that our answer is 6.0 times 10 to the second newtons per coulomb, and that's the units. Remember your answer was 600, and you have to make that have two significant figures. So in order to make one zero significant but not the other, you have to use scientific notation. There's just not another way to do it.